will be performed by Omar Mohammed, and it's called Investigation of Micropitting and Wear in Rolling Sliding Contacts Operating under Boundary Lubrification Conditions.
Hello everybody, I'm Omar Mohammed. This work is done when I have been working at SIFT, which is the Innovation Center under Gilico, located in Gothenburg in Sweden. And recently I work as assistant professor at Mohammed University. This research topic will be about investigation of micropitting and wear, specifically for gears. So in gear failure we have different modes, and in this research specifically we will study contact fitting, micropitting, beside the wear. As you know, micropitting can be defined as microscale contact fitting, and depending on the size of the pits, can be named as macropitting or macro or even small. But when we say macropitting, it means not bigger than 10 microns. Here we can see the contact fatigue damage, which can be divided into 3 different phases. In the initial phase, when we have some changes in the material and the roughness and the residual stresses, before starting the bag or the failure. After that, the crack initiation as a second phase. Then we will have crack propagation, which is driven by Cartesian contact stress. Those factors have been considered in our study. It is the geometry, surface roughness, light to roll ratio, film thickness, lubricants, and the contact pressure and material. To represent our objective in this study, I can divide the work to 3 different phases. Phase 1, it is to study the slide to roll ratio, different values, where we have 1, 2, 3, and 1 repetition case to check the quality of the results. In phase 2, we will study different roughness. We have RI1, RI2, and RI1 with RI3. So we have different combinations of the 2 engaged wheels. And also we have 1 repetition case available. The third phase, we will have surface treatment that's done in collaboration with a company in Sweden which is called Applied Nanosurface, Björling. They have developed a new surface treatment for walling surfaces, and here we studied different combinations as well. First one without any treatment for both wheels, and then we will have surface treatment 1 with steel, not treated, then ST1 which is surface treated 1 and 1, then 1 with 1, but it's here it is the repetition of that one to check the repeatability, but here we will have 2 and 2. So we'll have 1 and 1 and 1 with untreated, then 2 and 2. Those surface treated, those roughnesses can be defined here with different values. And here we have our experimental setup that has been used. That's what we call a twin disc array. Now here we can describe the studied cases in phase 1 of different slide to roll ratio. These values, different cases. In gear design, when we change the parameters, then we have different slide to roll ratio. So it's important to study this parameter and how it affects on the micropitting and the weight. this case, definitely we will have the same lambda which describes the ratio of the roughness and the film thickness. In phase 1, I can summarize the results that we collected as this. Here we have inverse relation between the micropitting and the wear. The black one, it is the wear for the test 2, 3, 4. You can see it is increased, while the micropitting we get this. And that I can explain because when we have more wear, then there is the micropitting asperities will be wiped off. So it will not be, we will not see any micropitting because the asperities of the surface will not because of the wear. So that's why this behavior you can see. We check 2 different periods of the test. 1.5 million cycle here, this one, the Roland one, and the green one it is 4.5 million cycle. But then we continue with 1.5. We see it's enough. No need to stay on that. By this long period, we can see they are close to each other. The amount of wear. The summary of this phase, we can see the inverse relation of wear and micropitting. And as I said, when wear is dominant, then the micropits start to wipe off. So we cannot see its high wear values. And for longer period tests, I mean the 4.5 million cycles, the amount of wear for the 3 cases, yeah, quite similar, as we have seen in the figure. Now for the phase 2, we studied different surface roughness values, as we can see here. Those values, we studied RA1 and 1, then 1 with 2, 1 with 3, then 3 with 3, then it is a repetition case to check the repeatability of the results. And we fix the other parameters, the slight error ratio, and the lambda will be affected because it is a ratio of the film thickness to the roughness. So that also will be different values, which is related to the roughness values. Here we can see also the inverse relation between micropitting and the wear. And then we, in this studied case, we can recommend this region because we will have some kind of compromise between the micropitting and wear because we want to satisfy both. So here we have the roughness, and here we have the lambda, which is related to the roughness. They show that we have the same relation, the same trend. This is the recommended value that we can draw from the results. It is to compromise the results of micropitting and wear as well. And here we can see different pitting propagation in different times. Here it is 2 hours, 4, then 8, then 16. So if we can summarize this second case, still we have inverse relation between micropitting and wear when we study different slight roll ratio, different roughness parameters, and we can see there is a proportional relationship of wear. When we have higher wear, then we can have so the proportional relationship with wear, and it will be opposite with the micropitting. And the minimum roughness will enhance the film thickness, so that will cause milder asperity for the contact. And definitely that will reduce the amount of wear. The third phase now, which is the surface treatment, it is done by some process developed by Applied Nanosurface Technology company, and this technology, it is basically chemical and mechanical triple conditioning of the surface, and they can add the anti-wear film and tend to 100 nanometer thickness of some treatment, which is mixed of different elements. So let's see the effect of this surface treatment. But before that, we can see the different combinations that we have been studied. Here we can see the surface treatment, one with untreated, and one with one, and this is repetition, then three with three. And definitely we can study or compare the results with the untreated that we got from the previous phase. Here we can see the surface treated one, and this is two. You can see not much difference, but in surface treatment 2, you can see significant improvement, which is the same concept but different parameters they can do in the surface treatment. That's why this one, so they can develop different surface treatments. And here we can see the difference between surface treatment 1 and 2, and it shows more improvement or reduction in the roughness, and the same for the peak. The result of this third phase of surface treatment, as we can see here, this is for untreated and treated, steel with steel. So we can compare with when we have the surface treatment 1 with untreated or steel, then we can see the micropitting initiation is more. So here at 2 we have some amount of micropitting, but here at 2 it is a very small value for the wear and almost zero at micropitting. For surface treatment 1 and 1 for both wheels, we can see this behavior. When we have higher wear, micropitting also shows some reduction. When we have, this is a repetition of that case. But here when we have, it is the same repetition, but here when we have the 2 with 2, that will show a good reduction, as you can see here. Because as we saw, the surface with 2 show better results. Now if we summarize the results of this phase, so we can see the best we can have here when we have the hybrid case, surface treatment 1 with untreated. It's better than we have both treated here. So this results shows lower values. And better than this, it is the case when we have surface treatment 2 for both wheels. We can see even lower result than what we have in testing. The same values that we got in the table, we can in the graphs, we can see it here as a table. Now the summary of phase 3, we can the micropitting and wear seems to decrease using the removal of fatigue layers, and the surface treatment 2 gives better results than surface treatment 1, and the hybrid case of surface treatment 1, when we have one treated, one untreated, that shows a better result than both treated and surface treatment. So our recommendation it is to from phase 1, it is to lower slide to roll ratio is better in terms of wear, and that's reasonable. In phase 2, we can recommend this amount of roughness and the connected value, which is 0.19 lambda for the studied case. But we can find the same for other cases. And in phase 3, we can recommend the surface treatment 2, which performs better.
Thank you. Questions? No? Okay, so to be in time, we will pass to the next presentation. that will be performed also